Statistics. It is not a science but a scientific method. It is a branch of applied mathematics, and the father of statistics is R.A. Fisher. It can be expressed in quantitatively or qualitatively. With the help of this, government can do proper planning. It is used as both singular and plural term. Some limitations of statistics are: it is not applicable for single observation as it is the sum of total observation. It deals with population, not an individual. Always have certain amount of error. True on an average only. It can be misused. Types of statistics. Different types of statistical methods are descriptive statistics, inferential statistics, applied statistics, mathematical or theoretical statistics, statistical methods and functions. Classification and diagrammatic representations are come under descriptive statistics. When we draw conclusion about population, it is come under inferential statistics. Population, census, national income, production, quality control, business, industry, biostatistics, all these are come under applied statistics. Statistical distribution, sampling distribution, design of experiment, then real life problems, everything is come under mathematical or theoretical statistics. It is also widely used in statistical methodology, statistical inference, and fundamental statistics. Then collection, tabulation, analysis, interpretation of data, these are come under statistical methods and functions. Now the main functions of statistics are collection of data, presentation of data, analysis of data, and interpretation of results. That is, প্ৰথমতে আমি ডাটাখিনি কালেক্ট কৰিম, তাৰ পৰা আমি সেইখিনি প্ৰেজেন্ট কৰিম, তাৰ পৰা আমি সেইখিনি এনালাইসিস কৰিম, আৰু তাৰ পৰা আমি তাৰ ইন্টাৰপ্ৰিটেশন কৰিম। Then data means information. Well, there are two types of data: primary data and secondary data. When data or information are directly collected from individual, then it is called primary data. And when information are collected from published or unpublished agencies like published papers, journals, various government non-governmental reports, then it is known as secondary data. When we collect information for a given purpose, then the data is reliable when it is complete, accurate, consistent, and homogeneous with respect to information. Now, presentation of data. Data can be presented in various ways: serial or alphabetic order, ascending order, and descending order. Statistical laws based on trial and error methods are law of statistical regularity, law of inertia of large number. When sample size are large, then it means more representative, and it is the law of statistical regularity. When large aggregate more stable, then now classification and tabulation. The process of grouping data into different categories based on the nature, behavior, and common characteristics is known as classification. And the process of summarizing data and presentation of data includes arranging classified data into rows and columns with heads and surface, and it is known as tabulation. First we do the data collection, after that we do classification, and finally tabulation is done. Now, another form of tabulation is diagram. Different types of diagrammatic representation are one-dimensional, two-dimensional, three-dimensional, and non-dimensional. Types of one-dimensional diagram are bar diagram, multiple bar diagram, subdivided bar diagram, percentage bar diagram, deviation bar diagram, dual-directional bar diagram, paired bar diagram, sliding bar diagram, broken bar diagram, and line bar diagram. Two-dimensional diagrams are rectangle, circles, pie diagram. And three-dimensional diagrams are cube, cylinder, and spheres. Non-dimensional are pictogram. And this is the frequency polygon. Histogram, it is a bar diagram of two-dimensional. It is suitable for group frequency distribution with continuous classes. It is not a diagrammatic representation, it is a graphical representation. It can be drawn for distribution with unequal class intervals by considering height of the bars proportional to frequency distribution and frequency of class proportional to area of the rectangle. It is important to note that the approximate value of mode can be obtained from histogram. Ogive curve. The shape of the ogive curve is like elongated as prepared either for more than type or less than type. It intersects at median, useful for finding out quartiles, deciles, and percentiles. And This is the curve of less than type, and this is the curve of more than type, and these two curves intersect at median, and this is called Ogilvy curve. Now, exclusive and inclusive class interval. This is the example of exclusive class interval: 10 to 20, 20 to 30, 30 to 40, 40 to 50. Here, upper limit, that is this upper limit, is not included, but lower limit is included. And this is the example of inclusive class interval: 9 to 5, 10 to 14, 15 to 19, etc. Here, both upper limit and lower limit are included. Now, frequency. Frequency means number of times a varied value is repeated. It is known as frequency. And cumulative frequency means total number of frequency. Here, these are the frequency, and when we total these frequencies, this is known as cumulative frequencies. Now, measure of central tendency. It is for univariate data. Various measures of central tendency are arithmetic mean, geometric mean, harmonic mean, weighted mean, then median and mode, percentile, quartile, and decile. In arithmetic mean, all values are considered in its calculation. Different methods for calculating arithmetic mean are this, and this, and this is for combined data. Properties are here: sum of the deviation, that is summation of xi minus x bar, is always 0, and it cannot be calculated for open-end classes. When classes are open-ended, then we cannot calculate arithmetic mean. It is not always symmetrical, and extreme values affect its calculation. Geometric mean. This is the formula for geometric mean. Here, if one value is 0, then the geometric mean, then all values are, then we get 0. If one value is negative, then our geometric mean is negative. For combined group, geometric mean formula, the formula of geometric mean is this. It is used to find rate of the population growth, rate of interest, construction of index number, effect. It is not affected by fluctuation of sampling. Give more weight for small observation. Harmonic mean. And this is the formula of harmonic mean. H is equal to 1 divided by 1 by n summation of 1 by xi. That is, harmonic mean is equal to 1 divided by 1 by arithmetic mean. It is the reciprocal of arithmetic mean of given value. Here, none of the observation are 0, and harmonic mean cannot be defined for all the xi. And for frequency distribution, the formula of harmonic mean is H is equal to 1 by n summation of fi by xi. For weighted harmonic mean, the formula is H is equal to summation of wi divided by summation of wi by xi. Used for speed, time, rate, number of time produced per day, construct complete per year. This is the formula of weighted mean, where w is equal to summation of w by xi divided by summation of wi. Median. It is a positional variance, measures of location for. It is a measure of location for asymmetrical distribution, not affected by extreme observation. It can be calculated for ungrouped distribution or discrete distribution, and group data or continuous distribution. For ungrouped or discrete distribution, median can be calculated using this formula. When n is odd, we use this formula, n plus 1 divided by 2 term, and when n is even, n by 2 and n plus 1 by 2 term. And for continuous distribution, median is calculated using the formula L plus H by F into n by 2 minus C, where L is the lower limit, H means interval, F means frequency, C means cumulative frequency just above the median class. Median can be used to deal with qualitative data for determining values in a problem of wage distribution of wealth. Also, it can be used for open-end classes. Mode means maximum frequency. It is not unique. It is for when data is grouped, or for continuous frequency distribution. The formula to calculate mode is this. It can be used to find ideal size. Example, in business forecast, manufacturer of ready-made garments and suit. Some results using Arithmetic mean, geometric mean, and harmonic mean is if we have x1 and x2 random variable, then the arithmetic mean is x plus 1, x1 plus x2 divided by 2. Geometric mean is root over x1 into x2, and harmonic mean is 2x1 into x2 divided by x1 plus x2. Also, geometric mean is equal to root over arithmetic mean into harmonic mean. Harmonic mean is equal to geometric mean square divided by arithmetic mean. When 9 points divide into 10 part, it is decile, and this is the formula of decile, which is similar to median. And when 99 points divide into 100 parts, then it is percentiles, and this is the formula of percentile. For nominal data, we use mode. For ordinal data, we use median, and for interval data, we use mean. Then measure of dispersion. It is a measure of variation in the item. Dispersion means scatteredness. That is to see the homogeneity and heterogeneity in the distribution. Measures of dispersion are range in the quartile deviation, mean deviation, and standard deviation. Range. It is not a reliable measure. Range is calculated by using maximum value minus minimum value. When range is 0, it means all values are identical. Quartile deviation. It is also known as semi-interquartile range. To calculate quartile deviation, the formula is Q is equal to 1 by 2 Q3 minus Q1, where Q3 means third quartile and Q1 means first quartile. It is better than range but not reliable since it ignores 50% of the data. It is less affected and more flexible by total number of observations. Now, mean deviation. The formula of mean deviation is 1 by n summation of I goes from 1 to m modulus of xi minus a. Here, a can be mean, median, or mode. Better than range and quartile deviation. When mean deviation is minimum when deviation taken from median. Then standard deviation. Root mean square deviation is standard deviation, also known as mean square deviation, and this is the formula. It is denoted by sigma for population parameter. It is affected by fluctuation of sampling. Standard deviation ensure highest degree of reliability. Standard deviation not free from unit of measurement, and it is always greater than 0. And this is the formula for variance. Sigma square is equal to 1 by n, I goes from 1 to n, xi minus mu whole square when for population, and for sample, s square is equal to 1 by n minus 1 summation of I goes from 1 to n, xi minus x bar whole square. Variance, standard deviation, and mean deviation are independent of change of origin but not scale. It is important. For combined data, variance is calculated using this formula. Variance is the minimum value of mean square deviation, and standard deviation is the minimum value of root mean square deviation. Variance tells about total clustering of data. Variance tells about total clustering of observation. Measures errors in representing all observation by a single value. Variance tells about clustering of the observation. It measures errors in representing all observation by a single value. More homogeneous means less dispersed. More heterogeneous means more dispersed. Pair of mean variance not uniquely determined by the distribution. Variance not measures degree of deviation from symmetry. Coefficient of dispersion. When we want to compare the variability of two series, যেতিয়া আমি দুটা সিরিজৰ মাজত ভেৰিয়েবিলিটিটো কম্পেয়াৰ কৰিব বিচাৰো, which are measured in different units, then coefficient of dispersion is used. Coefficient dispersion based on range is a minus b divided by a plus b. Coefficient of dispersion based on quartile deviation is q3 minus q1 divided by q3 plus q1. Coefficient of dispersion mean deviation is equal to mean deviation divided by average from which it is calculated. Coefficient of dispersion based on standard deviation is sigma by x bar, that is standard deviation divided by mean. Now, coefficient of variation. The formula to calculate coefficient of variation is sigma divided by x bar into 100. It is only useful when compare data with similar means expressed in different units. It is the percentage variation in mean, standard deviation being considered as total variation in mean. It is the percentage variation in mean, where standard deviation being considered as total variation in mean. Greater coefficient of variation means more variable. Less coefficient of variation means more consistent and or homogeneous. Moments. Probability distribution is not uniquely determined by its moments. mu1, mu2, mu3, and mu4 are central moments, where mu1 dash is and mu1 dash, mu2 dash minus mu1 dash whole square, and these are the raw moments. Moments is independent of origin and scale. And this is the formula for Seyfarth's correction for moments. It is important. When we use Seyfarth correction of moment, if frequency distribution is continuous and frequency taper off to 0 in both directions, then effect due to grouping at midpoint of interval can be corrected for calculate moments. First, it is used for both symmetrical and asymmetrical distribution. Also, it is important to note that for discrete distribution, beta 2 is always greater than 1. That is, variance is always positive. Skewness. Skewness means lack of symmetry. It study to see the shape of the curve. যেতিয়া আমি কাৰ্ভডালৰ শেপটো কেনেকুৱা হ'ব সেইটো চাবলৈ বিচাৰোঁ তেতিয়া আমি স্কিউনেছ ইউজ কৰোঁ। স্কিউনেছ আমি স্কিউড বুলি ক'ম, এটা কাৰ্ভক আমি স্কিউড বুলি ক'ম যদি মিন নট ইকুৱেল টু মিডিয়ান নট ইকুৱেল টু মোড হয়, মানে মিন মিডিয়ান আৰু মোড সমান নহয়। হুৱেন কোৱাৰ্টাৰ্ছ আৰ নট ইকুইডিষ্টেণ্ট ফ্ৰম মিডিয়ান, যেতিয়া কোৱাৰ্টাৰবোৰ ইকুইডিষ্টেণ্ট নহয় মিডিয়ানৰ পৰা, আৰু হুৱেন কাৰ্ভ ইজ নট চিমেট্ৰিকেল বাট stretched more to one side than other, then that is আমি যদি চাওঁ কোনবোৰ হ'ব এইটো আমি চিমেট্ৰিকেল বুলি কেতিয়া ক'ম যদি এইটো এনেকুৱা হয় সমান, দুইটা চাইডে সমান 50%। কিন্তু যদি কাৰ্ভডাল এনেকুৱা হয় বা এনেকুৱা ধৰণৰ হয় তেতিয়াহ'লে আমি এইটো কি বুলি ক'ম স্কিউনেছ, কাৰণ ইয়াত মিন মিডিয়ান মোড সমান নহয় আৰু কোৱাৰ্টাৰ্ছবোৰ ইকুইডিষ্টেণ্টত থকা নাই মিডিয়ামৰ পৰা। মেজাৰ অফ স্কিউনেছ is calculated using these three formulas. SK is equal to mean minus median, SK is equal to mean minus mode, or SK is equal to Q3 minus median minus Q1. Relative measure. Coefficient of, to see the coefficient of skewness, three methods are Professor Carl-Patien's coefficient of skewness, Professor Bowley's coefficient of skewness, and coefficient of skewness based on moments. Professor Carl-Patien's coefficient of skewness, here limit is plus minus 3. And this can be calculated using the formula skewness is equal to mean minus mode divided by sigma, or skewness is equal to 3 mean minus median divided by sigma. And this formula is used for moderately asymmetrical distribution and when mode is ill-dependent. যেতিয়া মোডটো ভালদৰে আমি দিয়া নাথাকিব তেতিয়াহে আমি এই 2 নম্বৰ ফৰ্মুলাটো ইউজ কৰিম, আৰু জেনেৰেলি আমি এই ফাৰ্ষ্ট ফৰ্মুলাটো ইউজ কৰিম। আৰু যেতিয়া আমাক ক'ব যে স্কিউনেছটো 0 হয় তেতিয়া আমি বুজিম যে সেইটো চিমেট্ৰিকেল ডিষ্ট্ৰিবিউশ্যনটো চিমেট্ৰিকেল হ'ব, আৰু সেইটো মানে হৈছে বিটা 1 টো 0 হ'ব, আৰু তেতিয়া কাৰ্ভটো এনেকুৱা হ'ব য'ত মিন ইজ ইকুৱেল টু মিডিয়ান ইজ ইকুৱেল টু মোড হ'ব। আৰু আমাক যদি কয় যে স্কিউনেছটো পজিটিভ হৈছে তেন্তে আমি বুজিম যে কাৰ্ভডাল এইটো চাইডে যাব এনেকুৱা হ'ব, য'ত আটাইতকৈ ডাঙৰ হ'ব মিন দেন মিডিয়ান দেন মোড, আৰু এইটো হ'ব এচিমেট্ৰিকেল ডিষ্ট্ৰিবিউশ্যন। আৰু যদি স্কিউনেছটো নিগেটিভ হয় তেন্তে কাৰ্ভডাল এইটো চাইডে যাব, আৰু তেতিয়া মোডটো আটাইতকৈ সৰু হ'ব, আটাইতকৈ ডাঙৰ তাৰ মাজত মিডিয়ান থাকিব, আৰু আটাইতকৈ ডাঙৰ হ'ব মোডটো। তো যদি স্কিউনেছটো পজিটিভ হয় তেন্তে আটাইতকৈ ডাঙৰ হ'ব কি মিন, তাৰপৰা মিডিয়ান, তাৰপৰা মোড পজিটিভৰ কাৰণে। আৰু যদি স্কিউনেছটো নিগেটিভ হয় তেন্তে মিনটো আটাইতকৈ সৰু হ'ব, তাৰপৰা মিডিয়ান আহিব, আৰু আটাইতকৈ ডাঙৰ হ'ব মোড। নেক্সট মেথডটো হৈছে প্ৰফেচৰ বউলিছ কোফিচিয়েণ্ট অফ স্কিউনেছ। ইয়াৰ লিমিটটো হৈছে প্লাছ মাইনাছ 1, আৰু এই ফৰ্মুলাটো কেলকুলেট কৰিবৰ কাৰণে স্কিউনেছৰ ফৰ্মুলাটো হৈছে Q3 মাইনাছ মিডিয়ান মাইনাছ Q1 ডিভাইডেড বাই Q3 মাইনাছ মিডিয়ান প্লাছ মিডিয়ান মাইনাছ Q1। এইটো ইউজফুল হ'ব when quartiles and medians are used, mode is ill-defined and extreme observation are present. Distribution has, আৰু যেতিয়া ডিষ্ট্ৰিবিউশ্যনটোৰ কি থাকিব আনইকুৱেল ক্লাছ ইণ্টাৰভেল, when যেতিয়া ডিষ্ট্ৰিবিউশ্যন has unequal and open end classes তেতিয়া আমি এই মেথডটো ইউজ কৰিম। যেতিয়া ডিষ্ট্ৰিবিউশ্যন এই মেথডটো আমি কেতিয়া ইউজ কৰিম যে when quartiles and medians are used, mode is ill-defined, extreme observation are present, and distribution has unequal and open end classes. ইয়াতে Q3 minus median is equal to median minus Q1 হ'ব যদি স্কিউনেছটো 0 হয়, মানে এইটো চিমেট্ৰিকেল হয়। Q3 minus median greater than median minus Q1 হ'ব যদি এইটো স্কিউনেছটো পজিটিভ হয়, আৰু Q3 minus median to less than median minus Q1 হ'ব যদি স্কিউনেছটো পজিটিভ হয়। তাতে যদি স্কিউনেছটো +1 হয় তেন্তে median minus Q1 টো 0 হ'ব, আৰু যদি স্কিউনেছটো -1 হয় তেন্তে কি হ'ব Q3 minus median টো 0 হ'ব। তাৰপৰা আহিব কাৰ্ট'চিট। It gives the idea about flatness or peakness of the frequency curve and convexity of the frequency curve measured by beta 2 and gamma 2. The formula of beta 2 is mu4 divided by mu2 whole square, and formula of gamma 2 is beta 2 minus 3. And যেতিয়া কাৰ্ভডাল ওপৰলৈ যাব তেতিয়া আমি সেইডালক কি বুলি ক'ম লেপ্ট'কাৰ্টিক আৰু তেতিয়া বিটা 2 গ্ৰেটাৰ দেন 3 হ'ব আৰু গামা 2 গ্ৰেটাৰ দেন 0 হ'ব আৰু যেতিয়া কাৰ্ভডাল নৰ্মেল হ'ব তেতিয়া আমি সেইডালক নৰ্মেল বা মেছ'কাৰ্টিক বুলি ক'ম য'ত বিটা 2 ইকুৱেল টু 3 আৰু গামা 2 ইকুৱেল টু 0 হ'ব আৰু যেতিয়া কাৰ্ভডাল তললৈ আহিব তেতিয়া আমি সেইডালক প্লেটিকাৰ্টিক বুলি ক'ম আৰু তেতিয়া বিটা 2 লেছ দেন 3 হ'ব আৰু গামা 2 লেছ দেন 0 হ'ব